Hey guys, my name is Trevor Sullivan. I am a solutions architect with StratusGrid, and I'm also an AWS ambassador. Now, in an earlier video on the StratusGrid YouTube channel, which you can find over here on youtube.com/slash goforthandcloud, and what we talked about in a previous video on Bedrock agents is how to build a custom Bedrock agent from scratch. So essentially what this allows you to do is to implement programmatic functionality into large language models that you're ultimately calling through the various Bedrock APIs. Now, the agent service actually has its own separate runtime API from the typical APIs that you would use just to converse with a foundation model in Bedrock. So, if you do have an agent created, there's a separate API. But fundamentally, these are really the same things. They're all built kind of on top of these large language models. It's just that if you want to use agents in particular, there is a separate runtime API for that particular purpose. So, just be aware of that. Now, in this previous video, what we did in order to build an agent is we created what's called an Open API specification, and that allows us to define an API in code, and then we can use that API endpoint information to help kind of feed into our Lambda functions. But there's actually another way that you can build agents as well directly through the AWS Management Console. So that's what I wanted to talk about in this particular video. Now, the whole concept of doing infrastructure as code automation, in particular with large language models, not just doing automation by hand, but actually leveraging LLMs to automate that process for you, is becoming a lot more popular these days. One of the examples that I wanted to share with you as part of this video is how to automate the simple creation of an Amazon DynamoDB table using an Amazon Bedrock agent. So that's the demo use case that we're going to work through in this particular video. Also, make sure you check out the documentation on Amazon Bedrock. It is pretty thorough out here. So if you head out to the Bedrock user guide here, there is the section down here called Automate Tasks in Your Application Using AI Agents. And so this is really going to give you a breakdown on how to configure those agents and ultimately how to configure your Lambda functions to interact with those agents in Bedrock and do other advanced things like memory sessions and there's a new prompt caching feature that's coming out as well. It's in preview right now. But yeah, there's a lot of interesting things here. Another new feature that's recently been put into preview release here is called multi-agent collaboration. What this essentially allows you to do is have a parent or supervisor agent that can then orchestrate a series of child agents, and each of those child agents could be responsible for performing certain tasks within a segment of your business. And then you can have this supervisory agent basically handle delegation of tasks to those child agents, depending on what the user's request or prompt was into that parent or supervisory agent. So this is a really interesting feature that's coming out. I haven't had a chance to play around with it just yet as it is in preview at the moment, but you can actually access it straight inside of the AWS Management Console. Also, if we go one step up from the user guide documentation that really goes into the conceptual things behind how Bedrock works, there's also the API reference over here. And if you recall just a minute ago, I was mentioning how there's a separate runtime API specifically for Bedrock agents. So you can find that right here. It's called the Agents for Bedrock Runtime. If you're looking to create and manage and maybe even delete agents, you can do that using the Agents for Bedrock API. But if you're actually looking to invoke an agent that you've already created, either through the AWS Management Console or through the agent management APIs, then that is where you want to take a look at the APIs for the Bedrock agent runtime instead. So we've got the invoke agent API down here. There's also invoke flow if you want to use the prompt flows feature. We have some other videos on our YouTube channel that talk about that feature as well. If you're looking to use knowledge bases, you can use retrieve and generate or retrieve and generate stream as well here. So there's a lot of different APIs that allow you to interact with agents as well as prompt flows and Amazon Bedrock knowledge bases, which allows you to do retrieval augmented generation, also known as RAG for short, which is a pretty popular concept that helps you to bring your private proprietary business knowledge into your large language models. Okay, so with that in mind, we are going to be focusing on just the console for now. I'll probably talk about the APIs in a separate video, but I did want to kind of walk through this agent creation so you have a feel for how to create a new agent without having to use the Open API specification that we talked about in the other video that I did a while back. So over here in the AWS Management Console, I'm in my development account here, and I am in the Bedrock console, which you can just search for right here in the unified search feature in the console. And what we want to do is go down to the Builder Tools Agents section right here. And there is the option to create a new agent. Now, when we create an agent, we want to give it some kind of name to describe what the purpose of this agent is for, just so we can recall this. So I'm going to call this Trevor AWS Manager. We'll just call it Resource Manager, maybe. And then we'll say for a description, the description is just metadata. It doesn't actually control the agent itself. So we'll just say we'll use this to control AWS resources from Bedrock. And then as you can see right here, we've got this checkbox to enable multi-agent collaboration. But if you don't enable this now, you can always go into the agent builder interface and enable that after the fact. So now we're in the agent builder interface. And if we scroll down here to the bottom, you'll see that multi-agent collaboration. And you can always click on edit and activate that, and then choose your child agents down here under agent collaborators. So if you're interested in playing around with that, I would encourage you to just think about kind of a logical structure of agents. So I might have one agent that's for managing DynamoDB. I might have an agent that for managing CloudFormation stacks. I might have an agent for doing S3 related tasks, or maybe like a data ingestion mechanism that I could use for ingesting records into Kinesis data streams. I mean, it's really up to you how you want to organize those. But the multi-agent collaboration just allows you to kind of build a structure, a hierarchy of agents, which is pretty cool. All right, so this time we're going to create an agent without OpenAPI. One of the first things we need to do is provide some high-level instructions for the agent. So one of the things you can do is in the agent is select a model that you want to use. I typically use the Claude 3.5 Sonnet model here. There is actually a newer Claude 3.7 model that recently came out as well. I don't think that is available for use inside of here quite yet. But they may add that in the future for agents in particular. But what I want to do here is basically provide kind of a high level instruction to the agent, like what is the agent's purpose? And so, of course, based on our name here, this agent is responsible for helping the user who's actually calling into the agent and providing a natural language prompt to manage AWS resources. So let's do something like you are an automation agent that is responsible for helping users manage various AWS cloud resources inside their AWS account. And then I'll give it some examples of things that it might be able to do. And I'll say you can do things like create an S3 bucket, delete a bucket, create a DynamoDB table, change the provisioning model of a DynamoDB table. And I could go off for, hundreds or thousands of different operations that I might do in AWS here, but I think that's pretty good for now. And I'll just say, or any other common AWS operations that involve creating, managing, creating, updating, or destroying resources. All right, that should be pretty good. So that's kind of a high-level description of what this agent's purpose is, right? And then I'm just going to go ahead and save that so I don't lose that paragraph that I wrote up there. And then what we want to do under the action groups section here is we want to define what are the different actions that this agent can perform. And so what we can do is create an array of action groups right in here. And this is where we can either use the OpenAPI schema approach and then feed that into our Lambda function, or we can just define a Lambda function directly. And that's the approach that we're going to take, is to just directly define the Lambda function, and you don't have to worry about learning how OpenAPI specifications work or anything like that. So what I'm going to do for this agent action group in particular is I'm going to tell this action group that it's for DynamoDB tables. So we'll say action group DynamoDB management. And again, this is just a metadata description. This doesn't actually functionally change the agent's behavior, but I'll just plug in a description here that says this action group helps managing DynamoDB resources. All right. For the action group type, again, we are not going to use API schemas. We're going to use the function details here. And what this will do is it'll give us a nice builder interface right inside of the AWS Management Console so that we can just kind of point and click and specify all of our different input parameters. And then I'm actually going to show you on the Lambda function code side in Python in particular, how you can extract parameter values so that you can use those parameter values inside of your Lambda function and actually create a DynamoDB table. I'm also going to go ahead and open up the DynamoDB console here. If you're not familiar with DynamoDB, there are some fundamentals that you'll want to be familiar with. When you create a table has to have, at the bare minimum, a name and a partition key. And the partition key can be a string, number, or binary. That's just how the DynamoDB service does internal data partitioning on different shards. And then it also has an optional sort or range key. You don't have to specify that, but it is sometimes advisable depending on how much data you're storing and the nature of the data structure that you're storing. But I'm probably just going to ignore the sort/range key for the time being, and we'll just focus on the bare minimum essentials, which include the name, the partition key, and then, of course, you also have to specify what cost model you want to use. So if you choose customized settings, there's the on-demand model where you basically pay for every single request, which is a little bit more expensive depending on the volume that you're doing. But if you're doing pretty consistent volume, you can actually switch to the less expensive provisioned model where you can pre-provision capacity, and then you're always going to have that capacity available. And as long as you're always consuming what you've provisioned, you're not really wasting any capacity, and you actually get a slightly lower rate if you calculate out the difference between on-demand versus provisioned. So there are some other settings here that are optional. You can have, secondary indexes. There's global and local secondary indexes. There's also the option to have warm throughput here, but most of these options you don't have to specify. If you just create a standard DynamoDB table, it's just going to do the standard table class here instead of infrequent access. It'll, you don't have to specify the warm throughput options here if you don't want to. You don't have to specify any indices if you don't want to, and things like that. So there are just going to be a few key parameters that we want to feed in. So what is the cost model? Is it on demand or is it going to be provisioned? What's the table name? And then what is the partition key? So those are the three input parameters we want to be thinking about as we are building out our agent. All right, so back here in our Bedrock console under the action group here, we are going to define a function. We'll say quick create a new Lambda function. That's fine. That'll set up the Lambda function along with the IAM execution role for that Lambda function. And then we'll have to go attach some DynamoDB permissions to the Lambda so it can actually go ahead and create the necessary resources in the DynamoDB API. So down here under action group function 1, so this is the first function that belongs to this action group. And we can have multiple action groups with multiple functions. So again, this entire action group is for managing DynamoDB tables. And the first function that I'm going to add is called create DynamoDB table. And then again, we have a meta description here for that specific first function in the action group. And I'll just say this function calls a Lambda that creates a function, or a DynamoDB table. That's what we're creating here. And then you also have this option here to enable confirmation. So what this will do is when you test out the agent in the right-hand test window here, you can actually get a confirmation prompt. So it'll basically say, all right, you asked me to do this, and in order to do this, I need to invoke this agent. Are you sure that you want me to invoke this particular agent with these input parameters or arguments? And you can just say either confirm or deny, and that will either allow the agent Lambda function to be called or not. Okay, so down here under the parameters section, this is where we can specify any inputs that we need in order to fulfill this particular action. So again, the action that we're doing here is creating a DynamoDB table. And in order to do that, we're going to have to add several different parameters. The first parameter will just be the table name. So I'll just call it table_name. And then this meta description here helps the large language model to understand the intent of this input argument. And so that way it can properly parse out the exact value from your prompt to feed into the correct parameter in order to call that particular function. So we'll say this is the name of the DynamoDB table that you will create. It's pretty self-explanatory, I think, right? And then we're going to set that parameter to be required here. because it is an absolute requirement to have that so that you can create a DynamoDB table. And then we're also going to add another parameter here called the cost model. You can call that, again, whatever you want to. I'm just going to call it cost model. And then we'll say this determines if the DynamoDB table will use on-demand or provisioned throughput mode. And then we'll set that to required as well. You could set that to optional and just have the default to be on demand, but I'm going to set that to required here. And then I'm going to also specify that it has some valid values. So I'll say valid values include either on demand with no dash in it or provisioned. So I just want to be really explicit about the two values that this supports, because when I go into my Lambda function code, I'm actually going to have to check the value that was fed into this cost model parameter and say, if it's on demand, then I want you to run this, or if it's provisioned, then I want you to do this. So we need to be able to have a predictable value that it's going to feed in for that argument so that we know how to check for it inside of our code. All right, the other thing we're going to do here is add in the partition key, also known as the hash key. So I'll just call this hash underscore key. And then we'll say this is the partition slash hash key. I just want to use both terms there so that there's no ambiguity. If the LLM thinks of it as the partition key and I feed it in as the hash key, then I want it to be able to basically combine those concepts and say, oh, you're talking about the same thing that I am. So this is the partition or hash key that will be used to create the DynamoDB table. And then, of course, that is going to need to be a required parameter here as well. So we'll set that to required true. All right, so we can either add another function, in which case we could do something like, update DynamoDB table or, delete DynamoDB table, and we could continue adding more and more functionality here. But for the time being, I'm just going to stick with a single action. So we don't need this second one here. So let me see if I can figure out how to get rid of that really quick. As you can see, there is a delete button right here on each of those functions. So we'll just click on delete and then confirm that we want to delete that. And then now that we've got our create DynamoDB table function here, we'll go ahead and just click on create for that agent action group. Again, this is an action group that can contain multiple individualized actions. So what this will do is it'll actually create a Lambda function for us in the same region. So we're currently operating in the Bedrock service in the Oregon US West 2 region. And if we navigate over to the Lambda service, so I'll middle click that to open it up into another tab right here, you should see a new Lambda function created, and you can actually see inside of the action group right here which Lambda function it is. So it's called action group DynamoDB management WFEQL. So that's just kind of a random 5 characters that it sticks on the end to make sure that the name doesn't conflict with other names in your account. And so we're looking for that WFEQL. Let's go back over here to Lambda and just do a search for WFEQL. And sure enough, there it is. So now what we can do is open up this Lambda function and we can see the actual Lambda function code. One of the things that the Bedrock service doesn't do is it does not automatically parse our parameters. What it does do is it extracts the parameters from this event input right here as a list of items. And so what we need to do is actually take this list of parameters that we get. In our case, we have 3 parameters that we've defined as inputs, and then we need to extract the values that were actually passed in for each of those parameters. Now this part, if you're brand new to Lambda, if you're brand new to AWS, or even just brand new to Python or anything like that, this part can be a little bit confusing because the parameters variable right here is actually a Python list, or also sometimes known as an array of items. And each of those items or objects, or in this case, they're called Python dictionaries, each of those dictionaries contains the name of the parameter and the value of the parameter as well, and the data type of the parameter. So each of the items in this list, we have to basically iterate over this list to find the parameter that we want. I think it would actually be easier if this was passed in as a dictionary, because then I can just index into that dictionary, find the dictionary key that I want, and then extract the value for that parameter. But unfortunately, there's one extra step where you have to find the item in the list and then extract the value from that dictionary item. So there is one step there, but we'll work our way through it. So what we want to do is create new variables that extract each of those arguments out of this Lambda function. What I'll do for starters, just to kind of show you the values being passed in, is I'm just going to add a print statement up here and say print the parameters. So I'll say print format, and then we'll pass in parameters right here. I think I could actually simplify that by just putting parameters in here, and then I don't even have to call format right there. And then I'll click on deploy here to publish those code changes for the Lambda function. So now the Lambda function isn't actually going to do anything, but at least it'll print out parameters here so I can see what data structure that contains in the CloudWatch logs. If I go to the monitor tab and click over to the CloudWatch logs right here for the Lambda function, I can keep an eye on this CloudWatch logs group that was created specifically for this Lambda function. And it doesn't exist yet because it's never been invoked before. But once I invoke the Lambda function, this log group will exist, and then there will be log streams down here that allow me to see the actual logs from the Lambda function. So before we actually implement the functionality, I just want to inspect that parameters variable to make sure I understand what the data structure is so that I can then extract the parameter values from those child data structures. So back over in the Bedrock console here, what we're going to do is to just test out this agent. So click on this right-hand side option here, and what that'll do is open up the testing section for the agent. And then if we go up to the agent builder here in the breadcrumbs, and then just click on save, that will update everything, and this prepare button should turn white so we can actually click on it. So then we'll click on prepare the agent, and then once the agent has been prepared, then we can go ahead and enter a prompt. So I'm just going to enter something really generic and just say new DynamoDB table. And I'm just going to give it a name like Trevor-SG-823. Part key is going to be, let's say, last name, last underscore name. And then the provisioning mode, it will say cost is on dash demand. And I'm going to put the dash in there because I want to see if it normalizes the on dash demand to just on demand without the actual dash. So you can see this is a pretty vague statement. If I was a human reading this, I wouldn't necessarily easily be able to parse it unless I really thought about it. It's like, okay, new Dynamo table with this name, part key. If I'm not familiar with Dynamo, I might not know what a part key is. And so it's kind of confusing here. But we're going to see if the model Claude 3.5 Sonnet from Anthropic is able to parse this. So we'll say run. And what we want to do is say, are you going to parse those values correctly and feed them in as parameters? And check it out. It says in this confirmation dialog right here, here is the action within the action group that I'm going to call. And here are the input arguments that I'm going to pass in. So it says for the cost model, it's going to be on demand. And as you can see, it did remove the dash based on the instructions that we specified when we defined that parameter on the action group. For the hash key or partition key, I abbreviated it in my prompt to just be part key. But part is just short for partition, right? And so the large language model was able to extrapolate that part key actually means partition key, which actually should map to the hash key argument here. And that was correctly parsed as the last underscore name value, which is correct based on my prompt. And then thirdly, the name of the table is parsed correctly right here. So the language model is actually really intelligent. It's able to parse out these values. I wasn't completely explicit. I could change the verbiage around and put maybe the name last, put the cost model first, and then leave the partition key in the middle. And the large language model should theoretically be able to parse out those values and then map them to the correct parameters. So that's the real power of what's happening here, is we're allowing all sorts of different people using different types of natural language prompts to express what their intent is, and then we're trying to normalize that using the language model to feed in these arguments to the necessary function that's running in Lambda. So we'll say confirm. And again, we haven't implemented the functionality in our Lambda function yet. So right now it is going to call the Lambda function, but the Lambda function isn't going to call out to the DynamoDB service until we actually write that code. And so as you can see, it says, this table's been created successfully. At least it thinks it's been created successfully, even though it actually has not. If we go to the DynamoDB console over here and just refresh, I had 6 tables before, and I still only have 6 tables. I don't have Trevor-SG-823 or whatever that name is that I came up with. So what we want to do, though, is actually take a look at the logs for the Lambda function. So here's our Lambda console, and then I should have another tab here for the CloudWatch log group. And so the CloudWatch log group is just /AWS/Lambda, and then the name of my action group. So if we reload this here, we should have a log stream now that it has executed at least once. And as you can see, we've got the log stream. And if you take a look here, it's parameters. So I actually need to go back and change my function code. I think I had it right the first time. I thought I could just feed that in there with the format operator. I think I actually need to prefix it with an F there. I think that is what I missed doing. So we'll just specify F there to use format strings. And then we'll go ahead and just try it again. Now, one of the cool things is that because the language model has this previous history or memory, I can actually just say, do it again, or try again, or any derivative of that. And it is going to simply try to reconfigure that or recall that function again. Now, in this case, you can see that it's complaining because it can't create a duplicate table name. So that's actually a new bit of functionality that I didn't notice, but it is making a pretty big assumption there. So what I am going to do is just click on prepare again right here, and then I will start a new session. And now we'll go ahead and do the same thing, say create table. Let's say create DDB table, Trevor SG 82895, and hash is going to be last name, and then we'll say cost is on demand. Let's see if that prompt works. It's a little bit different than what we had before, but in theory, it should still work. And so as you can see, it is grabbing cost model is on demand, hash key is last name, and we didn't even have to say hash key. We just said hash is last name, and it was able to correctly parse that. And once again, the table name is correctly being parsed. So we'll say confirm, go ahead and call my Lambda function again. And then we should be able to switch back over to the CloudWatch log group here. There's probably going to be a new log stream here because we made a minor code change. And as you can see, we have a Python list, and each of the list items here, here's the first item, that's cost model. Second item is hash key. And the third item is a dictionary containing the table name. All right, so what we need to do is actually write the code to find each of these parameters depending on what the parameter name is, and we can do that with a Python list comprehension. So what we're going to do is create a few new variables here. So after we print the parameters, we'll just say, all right, create a new variable called table name, and we are going to use a list comprehension and say x is going to grab the value for x in parameters if x name is equal to table name. And then if we wrap this in next here, this should extract the value field from the dictionary for the dictionary item that has a name of table name. So this is where it gets a little bit confusing, but if you use this syntax here, it should correctly parse out one of those arguments. And we can simply follow this pattern for the other parameters that we are passing in here. So I'll just go ahead and copy this line, and we'll just duplicate it a couple times. And then we're going to create a second variable called cost model, and we'll set that to cost underscore model. I think that was the correct one here. So it's actually cost dash model. I changed my nomenclature there, but I had hash underscore key. I did cost dash model and then table underscore name. So we'll do cost dash model is the value we are checking for. We'll assign that to this variable called cost underscore model. And then finally, the hash key variable will be the value of the hash key parameter. Okay, so let's go ahead and try that. We'll do a print statement here, and we'll do a format operator, and then say table name is, and then we'll pass in table name, and then say cost model is the cost model, and hash key is hash key. Cool. So let's go ahead and deploy those changes to our Lambda function here. And then to avoid any duplicate names, we'll just go ahead and copy our prompt here, and I will specify a slightly different name. So I'll just put in another number inside the table name this time. And then we can go ahead and validate that these were parsed correctly. So we've got on demand, hash key last name, and the table name. So we'll go ahead and confirm that. And then this will call the Lambda function again. As you can see, it was successful there. But of course, we don't have a table because we still haven't written the code that actually creates the table. But if we come over to the CloudWatch log group and look at the latest log stream right here, should have the latest event timestamp, you can now see table name is X, cost model is Y, and hash key is Z. Okay, so now we are correctly parsing the arguments from our Lambda function. So the last step here is to actually write the code that actually creates the DynamoDB table. So one of the things that we can do is leverage an AI model to actually write that code for us. So I'm going to go over to grok.com, and this is the Grok service from xAI. And this is a really great model. They just released Grok 3 recently, and it generates some pretty accurate code. So I will just say, show me an example of creating a DynamoDB table from Python 3 or Python with Bodo 3. And as you can see, it generates a pretty quick sample here. And Bodo 3 is already included. That's a module that's already included in the Lambda environment. So I don't have to worry about installing any third-party modules, which is one nice thing about Lambda. As you can see, it creates a resource object right here for the DynamoDB service. I think we can use that. There's also a client API as well that we could potentially use, although I don't know if that's totally necessary. I'm just going to rely on this for now. And then we'll come back here to our Lambda console, and we're going to say import Bodo 3 because we need to be able to reference that. And then after we parse out all the values, we'll just create that DynamoDB client, and then we'll call DynamoDB dot create table. And let's go back over here to Grok. And so we've already parsed out the table name, so we don't need to define a table name variable. What we care about right here is calling this create table function, where we pass in the table name, we specify the key schema, which is going to be which attribute is going to be the hash key. And we've already parsed that out as a variable as well called hash_key. So we'll just substitute that for user ID right here. And then for attribute definitions, we're just going to hard code that as a string data type, but you can also support binary types and number types in there as well for the supported partition and range keys. And then for the billing model, if you're going to use provisioned throughput, then you specify the provisioned throughput parameter here. But if you are using the standard on-demand billing model, then you would actually use billing mode equals, I think, pay per request right here. So that is going to be the parameter that we care about if we use the on-demand mode. So we have to kind of have some conditional logic inside of our Lambda function that checks that cost model and says, are you using on-demand or are you using provisioned? And based upon that input, we can then either choose to specify provisioned throughput as an additional argument or not. But I'm going to keep things kind of simple right now. So we'll do create table. We'll specify the table name argument here, and we'll pass in the table name variable. And then for the key schema, I'm actually going to let the built-in AI here in the Lambda editor go ahead and complete that for me. I'm going to complete the key schema, and as you can see, it already substituted the attribute name, which is really convenient. Same thing for the attribute definition. The attribute name is going to be the same for the key schema and for the attribute definition here. And then for the billing mode, right now it is just passing in cost model, but that's not going to work because cost model as we specified it in the agent action group, is either going to be on demand or it's going to be provisioned. And those are not supported values. It has to be set to pay per request because that's what the DynamoDB service API is expecting. So what we'll do here is say if the cost underscore model is equal to, let's say, what is it going to be? On demand, then we're going to call this, and we'll go ahead and change billing mode equal to pay per request. I think it's actually underscores instead of dashes. Let's just validate that here in our Grok output really quickly. So where is it? It's pay per request. I'm going to take its word for that for now. And then if it's not on demand, if it's set to provisioned, then we would use the other billing mode, which would be provisioned. And then we would also specify what the provisioned throughput is. And I'll just hard code some values into there just for the sake of example. Of course, you could add additional arguments to your agent action group in the Bedrock agent to capture the number of read and write capacity units. However, you will quickly run into a limitation where you can actually only have up to 5 maximum parameters defined on each of the functions inside of your action group. So be aware of that limitation. Don't go super crazy with your number of input parameters because you will hit that limit of 5 inputs really quickly. And of course, when you're creating a DynamoDB table, there's lots of different input arguments that you may potentially want to pass in, or maybe just use some sane defaults and then go back and tweak them later. So it's kind of up to you how you want to implement that functionality. But that's why I like to keep things simple here, is so I don't exceed that 5 parameter limit on each of those actions. So down here, we'll say if this, then do that. Otherwise, we're going to say create the table with the other mode. So I'm just going to keep this simple and copy this entire line here, paste it in. We'll set the billing mode to provisioned, and then we will pass in the provisioned throughput here as well. All right. And I think I can leave a trailing comma on there just for good measure. And I want to fix my indentation here as well. So we've got table name. We've got our hash key being passed in there as an argument. And we don't need to use the cost model because the cost model is being used on our if statement here. Okay, I think my indentation is all correct here. So hopefully this works on the first try. I am also going to move this print statement up higher. So even if for some reason these API calls fail, at least we still have the correctly parsed out variables right here. So we can see those in the logs, even if it fails down here for some reason. So let's go ahead and give this a try. So we'll click on deploy there. And again, just to show you in my Oregon region here under tables, I only have 6 tables. And then back over here under our agent, we don't need to make any further agent changes at this point because the only thing that we've changed is the DynamoDB service, or Lambda function, I should say. One thing that we do need to do, I'm glad I remembered this before I actually tried to execute it, is we need to make sure that the IAM role, the AWS Identity and Access Management role that is bound to the Lambda function, it's called the execution role. We have to make sure that that role right here that was automatically created for us when we created the agent action group, we have to make sure that this role has the necessary permissions to call the DynamoDB create table API. Otherwise, that Lambda function will run, and when it hits the line where it tries to call out to the Bodo3 create table function call, it will fail because the service is denied. So over in the IAM service, you will go to that role, which again, we just had directly linked here from the execution role under permissions, under configuration, under the Lambda function for that action group. And we want to make sure we say add permissions, and we'll say attach a policy. And I'm just going to take a shortcut for now and use this DynamoDB full access policy that's built into every AWS account. It's just automatically defined thanks to that little cloud icon right there. So then we'll say add permissions down here in the bottom right. And now that we've attached that policy, the next time that that Lambda function runs, the IAM role credentials that it uses dynamically will have permission to call the necessary DynamoDB APIs. Again, we would get an access denied message in our logs if we tried to call that without first assigning that permission. So we should be done with IAM there for the time being. So now that we've got all that stuff configured, let's come back to our agent here. And I'm just going to create a new session. Let's go ahead and save again. And for some reason, I can't click on end session there. Let's click on prepare again. I don't know why it's grayed out, but I seem to be able to click on it to end my session. All right, so now that we've done that, let's test out the agent. I'll say new table. I'll call it Trevor SG 38295, something kind of random. And then we'll say hash is last name and cost on demand. And I'll put a space in on demand and see if it's able to parse that into on demand with no space, which is what our parameter should expect. Let's go ahead and run that prompt. Again, we are executing in the Claude 3.5 Sonnet model. As you can see, it said cost model is on demand with no space, so that looks good. Hash key is last name, that's good. Table name is good. So we'll go ahead and just say confirm. And assuming that we get a successful response, which it looks like we didn't, we should have a new table, but it looks like that did not actually get created, or it looks like our function didn't respond correctly for some reason, but that API call did actually succeed here. So as you can see, we've got this new table here called Trevor SG 38295. And so we'd want to go over to the CloudWatch logs to actually see which part of it failed this time. And so let's go over to the CloudWatch logs console once again. And again, we're going to find our newest log stream here with the latest timestamp on it. And it looks like the Lambda function itself did actually run successfully here. But one of the common issues that you can come across with Lambda functions is that they can actually take a while to execute. And so it looks like what might be happening here is that we are hitting the 3-second or 3000 millisecond default execution time. And you can see it says status timeout. So everything inside of our Lambda function code actually ran successfully. And as you can see, it did actually create that table in the DynamoDB service right here. So that's actually working out just fine. The only part here that failed is that somehow the Lambda function actually did hit that timeout. So what we want to do is maybe just bump up that timeout a little bit, and it probably only hit that timeout because it's the first time that this particular version of the Lambda function ran. So those are what are called cold starts in the Lambda service. And so the first time that it's executed, AWS kind of instantaneously spins up a container behind the scenes, and it executes your Lambda function code. But in this particular case, that first execution just exceeded the 3-second timeout. So if we were to try to call it again, we should actually have a successful execution. So because it's already warmed up, let's just try something similar here. Let's say DynamoDB table, Trevor SG dash bacon, and then I'll say sort or partition key, party key will be, how about age? And then for the cost model, we'll say provisioned. And I'll just do prov for short to see how generic I can get with that parameter and still have the LLM properly interpret it. And so this time it looks like cost model is on demand. So that is not what I wanted. So I'm going to click on deny, and I'll just try this prompt again. Let's see if we can just copy that and then paste it in, and then say cost is provisioned. We'll be a little bit more explicit that time and see if it's able to capture that. And so this time, now it's correctly parsed that as cost model is provisioned. Okay, that's good. Hash key is going to be age. Table name is Trevor SG-bacon. That looks good. So we'll go ahead and confirm that. And hopefully, if our Lambda function is still warmed up, this should execute and actually return a successful result this time. So let's see. It looks like it did. So the fact that we didn't get the error message here like we did a little bit further up here means that the Lambda function actually did return successfully prior to the timeout period. So the other thing that you can do is if you do still hit that timeout, you can just go to your Lambda function configuration here. The default for Lambda functions is just 3 seconds. So if your code takes longer to execute than 3 seconds, it's just going to terminate it. But we could just bump this up and say, maybe I want to give you up to 6 seconds to execute, just so that when you do that initial cold start, it has a little bit of extra time to actually run. All right, so now if we go back over to tables and refresh our table view again right here, we should now have an 8th table called Trevor S.G. Bacon. This time we have age as the partition key right there. And if we drill into the cost model, if we go to additional settings here, you can actually see we have 10 read and 10 write capacity units provisioned, and we are in the provisioned capacity mode rather than on demand like this one down here. So the key takeaways that you should be learning from this is that you can create your own agents here. You don't have to know the OpenAPI specification syntax. It's kind of hard to remember that stuff. So without some additional tooling, it can be kind of hard to write OpenAPI specifications, but you don't have to know that at all. You can literally just come into the agent builder here. You can add in an action group here. And then within that action group, you can define your individual actions that you want to perform. You can express your parameter here, up to 5 parameters per action, and then you can simply call out to your Lambda function, and then you can use those input parameters that you're feeding in from the agent function definition here and simply parse those inside your Lambda function code, just like we did over here. And then once you've parsed out those variables using this list comprehension syntax here, along with the next function, to grab the first item from that list comprehension, then you have these handy variables that you can just use to feed into various function calls like we did down here with the create table operation. So it's really up to you to kind of be creative as a developer and think about, what are the different common actions that I want to be able to perform? How can I automate those actions using agent action groups in Bedrock? And then also we briefly touched on the fact that in the individual agents here, you can actually create that supervisory agent. If you recall at the beginning of the video, we talked about multi-agent collaboration. So I can define a bunch of different agents with different action groups with individual actions that can perform specific tasks on specific services. But then I can kind of orchestrate all those services together by creating a parent or supervisory multi-agent collaboration agent that is able to handle things one step above that and then delegate out the request to different agents depending on what your prompt is in your input. So I encourage you to go into the Bedrock console, play around with the Bedrock capabilities. The agent's functionality is really pretty cool because it's using an LLM to kind of parse out the intent from your natural language prompts, and it's able to grab specific values and then feed those in as parameters into your Lambda automation functions, and then kick off various types of automation tasks. So again, you can be as creative as you want to be with this, but I just wanted to demonstrate to you how you can do some basic infrastructure as code management using the Bedrock Agents service. If you're interested in StratusGrid helping you out, we have a professional services team that can help you to implement AI agent-based capabilities in your environment. So please reach out to us over at stratusgrid.com, and we would love to chat with you. So thanks for watching. Make sure that you like this video, subscribe to the channel. Also, just leave a comment and let us know what kind of topics you're interested in the AWS ecosystem. I hope that you are enjoying Bedrock and Bedrock agents in particular. It's a really nifty set of functionality, and it is evolving pretty rapidly as well. So thanks again for watching, and we'll see you in the next video. Take care.